This is my fourth video lesson on Unit 9. In this lesson, we'll be writing and balancing nuclear equations. Go to page 16 in the class packet. Motivation. What are the products when a radioisotope spontaneously decays? As stated from the previous lesson, radioisotopes are unstable and will spontaneously decay into a new element or isotope, releasing radiation in the process. The process in which a radioisotope becomes a new element is called transmutation. Take a moment to watch a TED video about this process. The link to the video will be in the descriptions. Pause the video and resume once you watch it. Learning target. At the end of the lesson, I'll be able to write and balance nuclear equation. Homework will be number 4, which will be a Junipod based off this lesson. There will be a quiz Junipod on PowerPoints 1, 2, 3, and 4. We're first going to analyze a nuclear equation. We first have our radioisotope. It will decay, releasing radiation and forming a new element. Let's look at an example. Let's say we have carbon-14, which is a radioisotope. When it decays, it releases a beta particle as radiation. The new element that's formed is nitrogen-14. Check of understanding number 1. How do you know what type of radiation is released if it's not given to you? So here they give us the radiation that's released as the beta particle. But what if it's not given to you? You have to look it up on table N in your reference table. Check of understanding number 2. What do you notice about the sum of the top and bottom numbers of the reactant side compared to the sum of the top and bottoms on the product side in the nuclear equation? Notice that they're equal. Notice that the sum of the top numbers on the product side is equal to the top number on the reactant side. For the bottom numbers is the same thing. The sum of the bottom numbers on the product side is equal to the bottom number on the reactant side. In summary, for a nuclear equation, the sum of the top numbers on the reactant side should be equal to the sum of the top numbers on the product side. The sum of the bottom numbers are also equal. The sum of the bottom numbers on the reactant side should be equal to the sum of the bottom numbers on the product side. Now we're going to go over the procedure on how to write nuclear equations for radioisotope. Let's look at an example. Here we have the radioisotope gold 198. The first step is to look at the element symbol and write the atomic number if it's not there. Gold have an atomic number of 79. The next step is to look up on table N for the decay mode of the radioisotope. On table N, gold 198 have a decay mode of beta minus. You can use table O to write its notation. To figure out the new element, we have to work backwards. We know the sum of the top numbers on both sides are equal, and the sum of the bottom numbers on both sides are equal. So we have to calculate backwards to determine the new element. X is our mass number, Y is the atomic number, and Z is the element symbol. So we have to work backwards to figure out each variable. What number plus 0 will give us 198? That'll be 198. What number plus negative 1 will give us 79? That'll be 80. That'll be the atomic number of the new element. To figure out the element symbol, you have to look at the periodic table and determine what element has atomic number of 80. That'll be mercury. So this is the new element that is formed in this nuclear reaction. Learning check number 1. Given the equation, which particle is represented by the letter X? Pause the video and resume as completed. If you look on table N, carbon-14 has a decay mode of beta minus. So the answer is choice 2. You can double check your answer by substituting the beta particle notation into X. Learning check number 2. Which nuclear equation represents alpha decay? Pause the video and resume as completed. So you're looking for a nuclear equation with alpha particle in it. So choice 1 and 2 are wrong. Choice 3 and 4 have alpha particle. But since it is decay, you are releasing alpha particle. So the answer is choice 4. Learning check number 3. Given the equation representing a nuclear reaction in which X represents a nuclei, which nuclei is represented by X? Pause the video and resume as completed. To figure this out, you must figure out the mass number and the atomic number of this element. 232 minus 4 is 228. 90 minus 2 is 88, so the answer is choice 3. Learning check number 4. Given the nuclear equation, the particle represented by X is what? Pause the video and resume as completed. So we know the top numbers must add up to 10 on both sides, so X must have a mass number of 9. So 3 and 4 are wrong. The sum of the bottom numbers must equal to 5. So X must have an atomic number of 4. So the answer is choice 2. For this practice, you're given radioisotopes from table N. Take a moment to write the nuclear equation for each radioisotope using table N. Pause the video and resume once completed. Here are the answers. Check of understanding number 3. When an alpha particle is emitted by an atom, the atomic number will do what? So it will decrease by 2 if you look at the examples. Check of understanding number 4. When a beta particle is emitted by a nucleus of an atom, the mass number of the atom will remain the same and the atomic number will increase by 1. You'll see this pattern if you worked on the problems. Learning check number 5. When an alpha particle is emitted by an atom, the atomic number of the atom will do what? Pause the video and resume as completed. The answer is choice 1, decrease by 2. Learning check number 6. When a beta particle is emitted by a nucleus of an atom, the mass number will do what? Pause the video and resume once completed. The answer is remain the same. Here's a summary table from your packet. Use it to study for the exam and for the Regents. Decay series is when a radioactive element keeps decaying until a stable element is formed. Sometimes a radioisotope decaying once isn't enough because the new element that is formed is still radioactive. So the new element will keep decaying until a stable new element is formed. This is known as a decay series. Here is a decay series of uranium-238. Uranium-238 is the parent isotope. The parent is the first radioisotope in the decay series. The products of the parent is known as daughter. So this is daughter number 1, daughter number 2, daughter number 3, and so on. Daughters are the decay product of the parent in the decay series. Now we're going to learn how to analyze a decay series graph. On the y-axis is the mass number, on the x-axis is the atomic number. So using the atomic number, we can figure out what element are we looking at each point. Each point represents an element or an isotope. Let's look at the first point. This point has atomic number of 92, so it is uranium, and has a mass number of 238. So this is uranium-238. The next point has atomic number of 90 and a mass number of 234. So this is Th-234. To figure out what radiation was emitted when it went from U-238 to Th-234, we have to look at the mass number and atomic number changes. So it went from 238 to 234, so it decreased by 4 in terms of mass number. And it went from 92 to 90, so it decreased by 2 by atomic number. So the first nuclear reaction is alpha decay. And this is the equation to represent that. To figure out the next nuclear equation in the decay series, we have to figure out what element is the next point. So this is 91 is the atomic number, and it has a mass number of 234. To figure out what radiation is released, we have to analyze the mass number and atomic number changes. So the mass number has no change, but atomic number has increased by 1. So this is a beta minus decay. Here's the equation of the nuclear reaction. The last point has atomic number of 92 and a mass number of 234. This is uranium-234. To go from Pa-234 to uranium-234, it undergo beta decay because the mass number did not change, but the atomic number increased by 1. This is the nuclear equation of step 3 in the decay series. This decay series of uranium-238 keeps going until it reaches lead-206 because it is a stable atom and not radioactive. You may notice a pattern in the decay series. The sloped lines represents alpha decay. The flat lines going from left to right represents beta minus decay. Flat lines going from right to left represents beta plus decay. This concludes the video lesson. Remember to do the Junipod homework and quiz.